Okay, so yeah, back, Emile, how do new RF and antenna technology enable scalable and cost-effective quantum communication satellites?
Well, I think having strong communication capabilities to and from space and between assets in space is of course the backbone that you need, and that's going to exchange the information that you will want to encrypt. So we're really very active at Swiss 12 on that layer of the infrastructure. We have innovated a lot in what's called payload technologies for radio frequency communications using novel technologies like 3D printing to essentially package the amount of data throughput that you would traditionally find in much larger satellites into much smaller satellites, which is very helpful to just disaggregate the infrastructure and to the point previously made, also create more layers to the infrastructure that can add resiliency to a global network. And then if you combine this with, for instance, quantum key distribution techniques, you can create a very safe and reliable network to communicate with.
And what is the regulatory aspect of it in order to establish those connections? Do you, yeah, maybe just...
So from a radio frequency perspective, of course, you needed an ITU filing to emit radio frequencies out of orbit. So this is a very well-oiled system that works since decades. But when it comes to optical, you don't. So when you work in the optical domain, you actually have very little regulatory limitations to establishing inter-satellite optical links, or even distributing quantum keys through optical means from orbit to ground or between assets in orbit.